Good day to all. Myself, Dr. B. Suresh Kumar, Department of Mechanical Engineering. In previous videos, we discussed about how can we perform the project work and how can we analyze the data. Likewise, we discussed. In this video, we can discuss with how can we generate the idea and how can we screen the ideas and how can we evaluate the ideas. Likewise, this presentation goes. Okay, that how can we create an idea for project work or product. Okay, here from lathe. This presentation is started from lathe. In lathe, the job is held between chuck and the tool is held on the tool post. Likewise, the initial setup is available. After that, if we may give the depth of cut with the tool post, the cross slide movement. Okay, from that we can actuate the tool perpendicular to the job axis. Okay, workpiece axis, which is known as depth of cut. The movement of tool with respect to parallel to the workpiece axis means which is known as feed rate, and the rotational speed of chuck is known as spindle speed. Okay, uh, these are all the fundamental thing we know. Okay, from this, how can we identify the problem? From that problem, how can we generate idea? How can we incorporate that idea into a product or project? We will see. Okay, then machining operation. Generally, the lathe is utilized for turn the jobs. Turning means you may reduce the workpiece diameter. So, turning operation for workpiece is also called as diameter reduction. This is the uh, basic definition. Okay, here you see the operation, which means basic machining operation. The tool fed perpendicular to the job and parallel to the. Here you see the cross slide. Based on the least count, he hit the uh, three divisions because the least count of the lathe is 0.01. So the operator decides 0.03 as the depth of cut, so that he utilizes three divisions for creating the 0.03 depth of cut. Okay, that turning operation is started. Here the scanning operation is carried out. The workpiece material removed in the form of chips. The chips may be continuous in this experiment. Here the tool is successors and the workpiece is mined steel. So the chip is removed as a continuous form. Okay. Here you see the operator decides to give 0.09 mm. For the reason he gives second pass, because every pass he gives 0.03 mm and the next pass also considers 0.03 mm. Okay, so that replaces the second pass for remove the material, which is another 0.03 mm. See, the tool removes the workpiece material in the form of chips of the same like continuous chips. Okay. The successor tool removes the mild steel workpiece in the form of chips with the next 0.03 mm. Now the operator operates the cross slide, which is the cross slide hand wheel. In that again he gives three divisions, so that the tool may travels against the workpiece axis another 0.03 mm. This is the third pass of the machine tool on the workpiece. This is the feed rate. It is parallel to the workpiece axis, which is known as feed rate, and the perpendicular to the workpiece axis is known as the depth of cut. So that the operator gives 3 times depth of cut for completing the operation, for reducing the diameter from 0 to 0.09 mm. Okay, so for reducing the diameter up to 0.09 mm, he utilizes 3 passes. Okay, here you see what is the problem. How can I develop the idea? You see here the problem is why I give 3 passes with the single tool. Okay, so that I generate new idea for solving this problem. Okay, for the reason how can we solve this problem? I can combine the tools, or otherwise initially I reduce the workpiece depth of cut with the 0.09 is a difficult task because the tool blends or workpiece surface finish is affected. So that how can I resolve this problem? Okay, which is the problem. Now you understand about the problem. Problem is how can we reduce the number of passes, and also how can we improve the surface finish of the workpiece. Here the productivity time is affected because the three passes of turning operation consumes more time. So how do I reduce the machining time? Here see the step turning in that it is not a step turning, depth of cut, three depth of cut I give. From this, first depth of cut reduces the first 0.03 mm, the second depth of cut reduces the second 0.03 mm, so that I can achieve 0.06 mm. Finally the point another 0.03 mm, it will reduces the 0.09 mm, so that I need now three passes for reducing the diameter from 0 to 0.09. Here see the 0.09 mm workpiece is final. Okay, from the final, for getting this final product I utilizes the three passes. How can I reduce the three passes for reducing the diameter at the same time, which is my initial problem? So I go for idea generation for reducing the number of passes. Here see, I combine. How can we combine tools? Here the single tool is available. The single tool is used for reduce the diameter, but the every pass consumes 0.03 mm, so that I utilize three passes for reducing the 0.09 mm. Now I generate the idea for reducing the productivity time and also the diameter. So I combine three tools on the same circle toolbar. I create a new toolbar with a different diameter. You see here the first tool, the second tool, and the third tool available. The three tools are adjusted with the aid of a screw. Okay, from this the screws can be controlled by I mean micrometer. From micrometer I can actuate the tool positions. The tool 1 gives 0.03 mm, another tool also gives 0.03 mm, and another tool also gives another 0.03 mm. The reference, the circumference may be differs. Okay, the tool position 1 is plus with the tool position 2 as like a 0.03, another 0.03. I may add another 0.03 with the tool 2 position. Likewise, I may add 0.03 mm at each tool post. Okay, so that the total circle has three tool posts. In that, every tool post consumes 0.03 mm. From that, I can reduce total 0.09 mm at single pass. This is known as product development from idea generation and problem. Here, the problem is poor productivity, and the idea generation is how can I combine the tool and how can I reduce the production time. Okay, at a single pass, with I mean with the single pass, so that I assemble the three tool posts on same circumference. From that I can achieve the so, 0.09 depth of cut and single pass. Can I achieve this? Is it possible? Yes, the new utilizing new machine toolbar for reducing the time. Here you see, yes, I attached the new developer toolbar on the carriage.
அவங்க இந்த
Okay,
பக்கம் மெட்டல்
from that
எடுக்கிறது இங்கே 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 அங்கே தெரியல மெட்டல் எடுக்கிறது
I can use the 0.03 mm depth of cut at each toolbar. Here, the first toolbar has 0.03 mm, another toolbar has another 0.03 mm. Likewise, another toolbar also gives another 0.03 mm, so that I can give 0.09 mm at a single pass. From this, I can achieve less productivity time. which is the idea generation and the problem solving in industries. From this, we can achieve the new product on machine shops. Okay, from this type of concepts also, you may create your mini project or minor major project. Okay, what type of analysis I can carry out through this means I can increase the material removal rate after and before machining. I can weigh at how much of time consuming. From this also I can estimate the material removal rate. After that, the second quality is the indirect proportion that, so that if material removal rate increases, the surface finish is affected. So I examine the surface finish finished by old method. You can see the surface finish occurred. And also I introduce new toolbar. From this also I can achieve the same surface finish. So that these kind of projects you should do with your curriculum or otherwise your subject. Okay, from this we can achieve the very simple or new product, and also we can apply this kind of product with the patent office also. You can get the patent and may you start your startup. Okay, from this you can earn the profit or money, and also you can earn the jobs. Okay, thank you.